So I went and I picked up this B grade 255 watt panel. And it's B grade because of that. Some epoxy or something got through. So I got this for 180 bucks. And I am attempting to move these capacitors out of the way. I'm attempting to stack these because these are only 10.8 volts to 28 volts, or 10.5 volts to 28 volts each. And this solar panel is 24 volts. Open voltage is, yeah, let's move this so we can see it. So this is the panel voltage itself, right there. And I want to know, will these stack in series? I already know they stack in parallel quite well, and we will find out. Here we go. The one turned on, the other one's off. Now they're both on. Now they're both off. Let's see what the voltage is doing. I'm wondering if I have to put a capacitor on the input on each inverter, and if that would work. Anyways, they're trying to work right now. They keep going default mode, I think, because of over voltage. And my watts in is doing nothing. Okay, so they don't like to stack in series, which is unfortunate. Okay, so that experiment failed. Now I'm going to hook these up to the back of each inverter to help smooth the power output, and we'll see if that works. Right, now I have this set up. So this capacitor is in line with this one in parallel, and this capacitor is in parallel with this one, and these are 20 volt capacitors. So one thing good about them is they will not surpass about 20.1 volts, or 21 volts I mean. Then there's internal resistance in here. If you try to put more than that with a lot of amps, they will actually get warm. So that'll restrict it. This is not permanent system or anything. This is just testing and seeing if I can somehow get these to work while I'm watching them, just to see what kind of output I'm getting from this panel that I just bought. If I want to do this permanently, I will buy a 24 volt grid tie. But anyways, let's check the cap voltage individually. So this cap, ooh, this is going to be hard with one hand. There we go. You got 13.3 volts. And this cap's going to be higher because this cap was hooked up longer. This one's 22.6 volts. So this cap is at its max volts. It won't go any higher than that. This cap is quite a bit lower, so I'm going to turn this one on first because that one's higher. And then I'll turn this one on. Now we're going to monitor the voltage of these caps now. Let's see what happens. They're both running at the moment. They're still both running. They're still both running. That one just shut off. This one's still running. Now they're both running again. So it is an improvement. They are running. Let's see, this one. Cap is 12 volts, 11 volts, 12 volts, 13 volts, whoops, 15 volts. Okay, and this one is 23, 19. Okay, let's see what kind of output we're getting, if we're getting any at all. Alright, what do we got here? Let's see, can you see this? Alright. 10 watts output, 9. It is very cloudy. Like, if I get 10% output, I am lucky. Because even my 1450 watt system is only producing 71 watts. Yeah. And between the two sets, 71 And the other set, the power factors went down. Something happened there. But anyways, it is producing 10 watts. Right now, 11 watts. And then it went down. See, they kick out every once in a while because it still drops below the voltage that the inverter can operate at. But let's see here again. See if it's stabilized at all. No, it still just goes up and down until it eventually stops working. And so does this one. That one's back going up. That's going to turn on, start kicking in some power, and it'll drop right back down again. It's the exact same thing. Look at that. Okay. Interesting. So I guess, unless I can figure out a way, oops, keep hitting the volume button. Unless I can figure out a way to limit each of these to about 15 volts each, maybe a bit higher, I can't stack them in series. Okay, thanks for watching, guys.